Lecture 9, Searching and Sorting. This lecture is actually about the use of a list. In the previous lectures, we mainly used tuples. Tuple, as you know, is immutable. That is, you can't change the content stored in a tuple. If you want to change, you have to use a new tuple to do so. And that increases the time and space complexity, as changing just one value means copying all the rest too to the new tuple. You can imagine lots of time and space would be needed if you need to do the changes often. Indeed, it is often in many applications we need to change the content stored. For that, we use list. In this lecture, we will go through list in good details. List, as you will see, is similar to array as used in many other programming languages. List, together with the programming construct loop, form the power of computations. That is, we write computer program with a few sentences and the program can do wonder because we have looping to help us to do lots of repetitive work and have lists to help us to keep track of the work. Instead of many fanciful applications with lists, we deal with two important tasks used in computer: searching and sorting. Think about them yourself. Whenever you turn on your computers, what do you want to do? Very often you are doing searching of stuff, and very often you do some kind of sorting so that your searching can be easy. Indeed, there are a lot to talk about searching and sorting. In the past, during my time as a student, we had a whole semester to talk about them. They are not just work on lists, but lots of computational techniques developed in the early days of computing. And they remain relevant till today if you wonder. Well, you may not realize as computers are so fast these days and searching and sorting are completed so quickly for the kind of data you have, and we thus took lots of such computation for granted. In fact, naive approach to searching and sorting can be very slow and unacceptable in real life. Let's begin. Tuple is immutable. So this tuple 1, 2, 3, if we try to change the first entry to 5, we get type error, as we cannot possibly assign a new value to an element of the tuple. What about list? List is different. For a list with 1, 2, 3, if you want to change the first entry to 5 to get 5, 2, 3, and this worked, that is, list is mutable. You notice here that we use parentheses for tuple and square bracket for list. For list, we use square bracket. When we type square bracket in idle, we get an empty list. If we type 1, 2, 3, we get a list containing 1, 2, and 3. We can check the type of list with type the list to get class list. We can also explicitly create a list with the keyword list to get an empty list, a list of 1, 2, and 3, a list with character A, B, and C, and to check the type of a list with type to get class list. Actually, we just saw the keyword list is to convert any sequence type into a list. Sequence here means a collection of items with order, where there is a first and a second and third and so on. Tuples are sequences and so are strings. Lists are also sequences too. So the keyword list also works on a list itself to give you another list of the same content. We see some simple examples of working with lists. Lists can be indexed. They can also be sliced. Creating a list using range operator. Range operator gives us 0, 1, 2, 3, 4. Then the list operator converts it to a list. A4 is the fifth element of A, which is also the last element in A. It is a 4. B is the list of A starting from position 2 to the end. Position 2 is 2 and to the end means 2, 3, 4. All these are not surprising, as we know lists behaves as a sequence such as tuple and string. Next, concatenation works for list too. C is a list of 5, 6, 7, 8, and 9. When C is concatenated to A, we get D starting from 0 till 9. When we want to append a new element to a tuple 1, 2, 3 with a 4, we write tuple 1 equal to tuple 1 plus 4, comma. But this actually created a new tuple TP1 at a different location from the original TP1. With list, we can directly mutate the list with the function append. List.append 4, then the resulting list is now 1, 2, 3, 4 while at the same location. We can check the location of the list with ID to know that this function doesn't change the location. Another way to append more than one items to a list is to use extend. We put all items in a sequence to get the original 1, 2, 3 extended with 4 and then 5 and 6. This is equivalence to saying given the list is added with another list 4, 5, 6 to get 1 to 6. But do note that plus equal operation is different from list concatenation. Although the results in both cases are the same, the list here in the first case remains the same location as the original, while the list here in the second case is now at a different location. A is this list. Delete A0 means to delete the item 0, which is -1. We will get the rest of the items, 1, 66.25, etc. Now if you delete the second till before the fourth, so we delete both these two, 333, we will get 1, 66.25 and the last item. Delete A from beginning to the end, so we get A as an empty list now. What if we do delete A without specifying any items? You should try this out. Here are some other useful functions that we encounter often. The length of a list, in this case 4, there are 4 items in there. The minimum among the values in the list, in this case is a 1. The maximum, likewise, we have 4. Is 1 in the list, in this case yes. 5 not in the list, that is true too. 1, 2, 3 as a list 2 times, you get 1, 2, 3, 1, 2, 3. We also have operations that mutate a list itself. For S, it's a list of 1 to 5. If you copy the list S to T, you get T 1 to 5. In this case, no change to S. S reverse, it's to reverse the items in S. In this case, from 1 to 5 become 5 to 1. At this case, T doesn't change, as T is a copy and not an alias of S. S insert 0, 1, that is to insert at position 0 with the item 1. So since S is 5 to 1, insert the position at 0, which means inserting at the front, you get a new 1 followed by 5 to 1. S pop is to take the last item in the list. In this case, the last item is a 1. So 1 is the outcome of this pop. S is then mutated by removing the last item. So we are left with 1, 5, 4, 3, 2. S pop 1 is to pop at position 1. In this case, position 1 is a 5. So 5 is the answer of this S pop 1. And 5 is gone. You're left with 1, 4, 3, 2. S insert 2, 2. At position 2, insert a 2. So position 2 means 1, 4, which is here. So you have a 2 added and followed by 3, 2 originally there. S dot remove 2 is to remove the first occurrence of 2 in the list. In our case, our list is 1, 4, 2, 3, 2. So the first occurrence of 2 is this 2. So this 2 is removed, resulted in S equal to 1, 4, 3, 2. S dot clear is to remove all items in S, resulted in an empty list. Here we can also iterate through lists using for operator. S is this list. For element in S, which means 1 by 1, we want to print the element, which we will print out 1, then 2, 3, 4, 5. We can also iterate to generate new lists. S is 1, 2, 3, 4, 5. If we do T equal to the new list, for each element n in S, we raise it to a power of 2. So 1 become 1, 2 become 4, 3 become 9, and so on. So this is something familiar to you. It is the same as T is the list doing a map on each element of S by taking the element, raise it to the power of 2. So we are done with the Python list. Lists are also sequences and can be used with all the sequence operations, just like those you saw in tuple and string. But lists and tuples and strings are different in that lists are mutable and have mutable operations on them, but not for the case of tuples and strings.